In this video, I'll be covering problems 6 and 7 from test review number 1. Alright, so for number 6, you are asked to graph this quartic polynomial. Things you should recognize right away are that it's a 4th degree polynomial with a negative leading coefficient, so we should expect that when we graph this in our calculator, both ends will open down. We should also recognize that because our constant term is negative 3, that it is also our y-intercept. So while it might be a little bit hard to read the x and y axis, and I hope it shows up okay as I'm recording this, but I do want you to graph all critical points. So let's just be reminded that all critical points include the y-intercept, which we know is going to be negative 3. We have to include the zeros, same as our x-intercepts. So I'll get those in a minute, and any maxes and mins. So I'm just going to make a list here and put my points, then I'll transfer them to the graph. So when I type it in y equals, and you pause if you need to, if you're doing this with me, go to y equals and type it in, then look at the graph. Well, as expected, we see that it does open down. In fact, it comes from negative infinity, goes up, back up, and back down. What we don't see very well are the maxes or mins, which means we probably could benefit from expanding our viewing window a bit. So I'm going to go to window and change my y max because I want to see higher on our graph. I'm going to change it to 20 and change our y min to negative 20 and see if that won't help. Well, good deal. Now I can see all of my points. So in terms of critical points, we already know that our y-intercept is negative 3. To find our zeros, recall that we need to go to y2, type in 0, and let the calculator graph a horizontal line at y equals 0. If that bothers you that you don't see anything because it is on top of the x-axis, you can move your left arrow over, hit enter once to make it bold, and then when you hit graph, it will graph y equals 0, which is a horizontal line, right on top of our x-axis. So there it is. So why do we do that? So we can find the intersection between our function and y equals 0, because on the x-axis, these 4 points that we need, our y-coordinate is 0. So to do that, we'll hit second trace 5, and we are going to find the intersection. It automatically defaults to putting the cursor at the y-intercept. I'm going to work my way from left to right, so I'm going to arrow left until I get all the way over to the leftmost 0. Just somewhere close in the vicinity is fine. It doesn't have to be directly on it. And we press enter 3 times. So notice the first one, and I do want these rounded to the 10th place, would be negative 3.90. And I'm going to expect all of these points to then be transferred onto the graph. Continuing on, I'm going to hit second trace 5 again, arrow to the right, and hit enter, enter, enter again. Getting my next 0 at negative 2.20. To find the third, I do second trace 5 again, arrowing to the right to get closer, enter, 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 negative 0.20. That 8 is going to make that 1 round up to 2. One last time, second trace 5, enter, 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 and my last one is at 1.90. So next we need to move on to find our max and mins. Please notice that we see 2 relative max points, so we are going to have to find the coordinates of both. To do so, we hit second trace maximum, hit enter, or second trace 4, and I always tend to find ones on the left first, so I'm going to arrow over, hitting my left arrow. And remember, this is pretty much the point we want, but we need it perfect. So we need to, it asks for left bound, so we're going to arrow to the left, go down a little bit, and hit enter. Then I'm going to arrow over on the right side and hit enter. Then it says guess, so I'm going to hit enter one more time. And I get the point negative 3.2 and 13. Now I need to find the other maximum. So second trace 4, I'm going to arrow right. This is the point. Right there is about the point I want, but we are not going to just trace it. We are going to move to the left, hit enter, move on the right side to set our right bound, hit enter, and enter one more time. It should always say maximum. That's how you know you're done. So our next maximum is 1.2 and 13. Next, for our min, second trace 3 will give us our minimum. But we want to find our cursor. It's where we left it. So now we want to arrow left. This is our minimum point. We're going to do the similar process. Arrow left, hit enter to mark the left bound. Arrow right to hit the right bound. And hit enter one more time. And we get the point -1, -12. Alright, so now I have the list of my critical points. Now my job is to transfer them onto the graph. So I'm going to start by recognizing if this is 10, then halfway is 5. So 3 would be right there, and I'm going to put a point. Oh, I apologize. That's a -3. That's not where I should have put it. Sorry about that. I need it at -3, so I'll say right about here. Put a point at -3. Let's see where I'll have some room to write an ordered pair. I'll just write it sideways. This is 0, -3. Alright, so check. I've got my y-intercept graphed. Now let's move on to points at -3.90. So that's on my x-axis. If this is -10, I would say that was 5. So almost -4, right about there is good. And I'm going to write in the order pair -3.90. Next, I move on. I've got that one. I'm going to move on to -2.2. Well, it's probably right about there. Let's see. -2.20. I need a point just barely past the origin. And let's see where I can write that, where it won't be in the way. -0.20. And then 1.90, so pretty much about 2, right? But that would be 1.90. Check, got that point. Now I need a max at -3.2, 13. So -3.2 is going to be somewhere in here. Go up to 10, a little bit more, right about there. Remember that these should be reasonable. It might be hard to see the paper, but it should be reasonable, and I, of course, should definitely see the ordered pair on the graph. That will also help you when you're writing your intervals. So that one's done. I also need one at 1.213. So notice I went, this was 0.2 and this was 1.9. That should have been -0.2. I'm really sorry. Let me just, that's on the negative side of 0. So -0.2. But 1.2 and 13, done with that one. And lastly, finally, last point, -1, -12. So there's -10, a little bit more would be -12. Now your job's to connect them. If I were you, I might do the order pairs in one color and then pencil or something so you don't end up covering over your numbers. So I know it kind of looked like an upside down, like an upside down W or maybe an M. So that's what it should look like when I connect it. Let's see. Is that a 0.2? You know what? I think I wrote that wrong. I think it actually is 0.2. Ooh, let me just fix all that. Looking back here on the graph here, I must have just wrote it wrong. So if I go second trace 5 again, enter, 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 it was positive 0.2. I'm sorry. Positive 0.2. 0.20. So back with my pencil, I noticed something seemed a little bit odd because I should be going through my y-intercept. So y-intercept, back through point 2, up to this max point, and back down. Notice, guys, that we should be going all the way down when we do arrows. Don't stop short. Go to the edge of your graph paper. So now we have all the information we need in order to graph this. And if you want to use colored pencils or highlighters tomorrow on the test, you're welcome to do so. So let's talk about our relative max. Please, please remember to state these at y at x. So this is 13 at negative 3.2 and 13 at 1.2. For our relative min, again, y at x, negative 12 at negative 1. And we are done with our max and mins. Do not look at these and think, oh, if one's higher than the other, I only pick the highest. You have to list all relative maxes, meaning anywhere where you see a peak or a valley. Intervals of increase, please recognize we read a graph from left to right. So if we start left, we're actually coming from where x and y are both negative in quadrant 3, and we will end up where our x's are positive and our y's are negative in quadrant 4. So I highly recommend that you write these ordered pairs up here to help you get your intervals correct. So remember, it increases, decreases, increases, decreases. So when you write your interval of increase, look at your x's and start left. So negative infinity up to negative 3.2. Then it begins to decrease from negative 3.2 to negative 1. Putting union in between our symbols, our intervals, we now increase again from negative 1 to 1.2. Then we decrease from 1.2 to infinity. So please don't, if you don't do this, you're more likely to mess up and put negative infinity because it's going down, but that's not how it works. You have to pick the x value, not the y. Okay? So please recognize up, down. So we should have increase, decrease, increase, decrease. So the number of changes here are 1, 2, 3, 4. That should be how many intervals you have. Next, if we do where intervals are, our intervals where f of x is greater than 0, please remember that that means above the x-axis. We can cover the bottom of our graph here and recognize we need to use our zeros this time and go from this 0 to this 0. It's above the graph from here to here and from here to here. So use your x's. So that would be from negative 3.9 to this x value of negative 2.2 union, and then from positive 0.2 to 1.9. If at any point you need to slow this down or go back and rewind, please do so or pause it. Intervals where it's below the x-axis, so that f of x less than 0. So I'll put up here below x-axis to help you remember. So that's going to be 3 different places. From here to here it's below, in the middle, and on the right side. So we have 3 intervals to write, okay? 3 intervals to write. It first, from left to right, from negative infinity to this 0 at negative 3.9. Then from this 0, negative 2.2 to 0.2. Then from 1.9 to infinity, using your x's. If you want to circle your x's like I did when I taught it, that might be a good idea. Next, it asks for end behavior. So that means we can use the signs of our quadrants, or these order pairs I wrote here, to help us write end behavior. So you have to write this statement. As x approaches infinity, f of x approaches blank. So remember, as x gets larger, approaching positive, our function is going down. But that means that our infinities in this statement should correspond to this ordered pair. So positive, negative. So as x is going positive, y is going negative. And then similarly, as x approaches negative infinity, going left, f of x is also going down. Oops. approaching, oops, left my negative off there, approaching negative infinity. So it should be just like our signs in the quadrant. We've talked about, if you just need to see it that way, this is positive negative in this quadrant and negative negative in this quadrant. So that should correspond positive negative and negative negative. Last one here for this video, number 7. Given the graph below, answer the following. You're first asked to state the minimum degree. Remember, we could just use our finger and trace from left to right, and however many times we count after turns, that's what our minimum degree is. 1, 2, 3, 4. So that should make sense because it's even degree because both ends go down forever. Because they go down forever, the sign of our leading coefficient, we know, is negative. The graph does go left and right forever, so domain will be all reals. The graph does not go up and down forever, but it does go down forever. So that means we need to do our lowest y to our highest y. Our lowest y is down here at negative infinity. Our highest y appears to be, if this is 10 and that's 15, that looks like it's about 13. You may have something close to that, as long as it's reasonable. And it does include, so we need to close with a bracket. So our range is negative infinity to 13 inclusive. Our end behavior will be similar to number 6, actually the same as number 6. As x approaches, remember in this quadrant it's negative, negative. So as x approaches negative infinity, f of x approaches negative infinity. And as x approaches positive infinity, f of x approaches negative infinity because it's going down. All right, feel free to rewatch any part of that you need.